Okay, welcome to the second of three climate lectures. All told, these three constitute the lectures for the single PowerPoint that's on Brightspace. The first part of climate was simply to talk about why climate is, what climate is, as opposed to weather in particular, what it includes as its climatic conditions. And then we went over why climate is an important thing for the built environment. Uh, and the main point of that overall, besides knowing various kind of pieces of it, is to understand that a stable climate is what has permitted us to make decisions over centuries about how we build. And as we'll get into now, we are involved in conditions of climate change that can disrupt that consistency that we've become so useful, and then therefore become kind of problematic for the built environment. With this piece, we're just going to talk about um, the I use the word contribution, but that makes it sound positive, and it's not. But the contribution of the built environment to carbon output, our role in that output. And then the next part that we'll talk about in the third and final short lecture is the steps we are taking as an industry. The industry of the built environment includes architects, construction managers, material producers, interior designers, everyone like that. What they're doing to mitigate the role that the built environment plays to reduce the detrimental dimension of the built environment. So we're gonna run through that now. So we're here to understand the role of architecture in the climate change. That's the role in contributing to the problem of climate change or carbon output, and therefore carbon outputs effect on climate change. We're going to talk about the relationship of the building industry to that climate change. And then, as I just mentioned, how designers and anyone in the built industry, in the construction industry, in the industry of making the built environment, what we play a major role in helping to reduce the deleterious effects of the construction industry on the environment and the climate. And before I jump into some of those other slides, I do want to kind of start actually with this one right here, because it points to the various or the life of a building and how the various phases of it are part of the role it plays in carbon output. And we often think of a building's contribution to um, uh, this carbon output as its operation, in the sense of how do I run it efficiently? How can I have it so it uses less energy and therefore is burning less carbon? But the fact of the matter is it goes beyond that. It starts simply with the production of the materials that will be used to build the building. So the raw materials, the manufacturing and the transportation of those materials so that they can arrive on a building site from a place like this, where quite literally they're harvesting out of the earth raw materials that will be made into building structural closure or any other type of building element that we can use to actually fabricate a building. And that moves then into the construction phase. And that is then all the energy that is used to fabricate a building, significant amount of waste that is created by that, but also the energy necessary to make it. And then the part we often think about, let me get it up here, get out of your way a little bit, is the maintenance, repair, replacement, refurbishing, and just the general operation of the building while it's in use, right? And um, that may not include significant amount of additional materials, right? It might not include bringing back aspects of this. Certainly when you're repairing and replacing and refurbishing, you might be, but certainly it's not at the scale. That's the operation really has to do with the energy use of the occupation of the building. Um, and then we have the end of life. And the end of life is what we do with a building when it's no longer in use. Um, the traditional way the industries of the built environment, and this includes real estate speculation and real estate development, is you tear that building down and all that stuff goes into a landfill. And as it does so, you're releasing carbon that has been, that sits in that material out into the environment. And so these 1, 2, 3, 4 phases of a building life really can impact that. There is conversation, and we'll talk about this a little bit more later, about what happens at the end of life. How can we actually um, either reuse buildings so there isn't an end of life, or how can we dismantle them in a way that allows us to reuse their materials um, to um, um, to save the production of new materials and all the carbon that's created there, and not just carbon but cost, and continue to use the materials that we have. It is worth noting that in the United States we have the amount of building stock um, uh, to to serve our needs for the foreseeable future. So we really don't need new buildings. Um, we just need buildings that are designed properly for what we need them to do, and that can often be very difficult. And also, we have some older buildings that have some hazardous materials built into them, and removing those becomes very difficult. And so, if we just kind of jump over to here and talk about for a moment, that initial step, right, of getting building resources, right? It's important to note, right, that buildings, this is on a global scale we're talking about now, they consume 40% of raw materials. So just under half of all the raw materials that we pull from the earth go towards buildings. That term buildings also includes some infrastructure, but it's really buildings. Okay. They don't just consume energy, but they also demand a significant amount of natural resources. The steel, the concrete, the iron, the aluminum, all those things that we use to build buildings require raw materials, right? This is an energy intensive process, labor intensive process, and it really depletes our resources. And as though we do that, as we're using energy to create those materials, it is contributing to carbon output and to climate change. Waste is a huge issue in the building industry that we generate, the construction industry, and not to tag them with this, but it's an industry issue for all those involved in the built environment. The 30% of global waste comes from the fabrication of buildings and other parts of the built environment, right? And the vast majority of that is it's not it's not recycled, right? Um, so this basically kind of restates those points. So to understand how much of the natural resources we use that we extract from the earth and the amount of waste really kind of are crucial elements here. For our purposes, what we just really going to go over are some more statistics about the building industry's role in creating climate change or contributing to climate change through carbon output. So if you look at all global emissions, and this is a really fantastic website, I'll just kind of mark it here, Architecture 2030. You really should visit it and check it out. That's who kind of produced these graphics. Um, the total um, uh, CO2 emissions, global emissions, can be roughly divided up into the categories that you see here. The shaded ones, buildings, which is buildings operations, buildings, which is its materials, and then this is infrastructure, roads and things like that. Um, uh, they contribute just about 42% of the global emissions, right? And so given that we produce almost half, just under half, just over 40% of the global emissions, it tells you that changes in the way that we build buildings and design buildings can have a tremendous effect, positive effect on CO2 emissions. This basically kind of restates what I'm just pointing out in the diagram. If we set aside the operations and we just look at the construction of a building and its materials, what you'll see is that you can break off cement and it produces a significant part of this a portion of it, more than half of the overall number, and more than iron, steel, and aluminum combined. And we want to look at those materials because it really starts to impact the choices that you'll be making as someone in the construction industry, when you're designing or constructing a building, what materials you're going to use, right? So cement is one of the real significant producers of CO2. And when we talk about cement, we want to be very clear that we're talking about the material that is an additive to concrete. We all know that concrete is not cement. Cement is used to make concrete. So concrete itself, people often say concrete's the problem. And yeah, it is a problem. But it's the cement within concrete. It's not the aggregate. It's not the addition of the water. It's not addition to other additives that we put in there for high strength and stuff like that. It's the cement. And the cement is what we're pulling from the earth, right? It is a raw material that you have to, I don't know, I'd say quarry, but you excavate, right? And pull from the earth. And as you do that, it's incredibly labor and energy intensive. And buildings utilize half of the cement, or in the overall use of cement, buildings are producing overall half of the CO2 from that use. So if this is all the CO2 being created by the use of concrete, buildings are producing half of that. So the construction, the use of concrete in buildings worldwide now, being clear about this, it's worldwide, is our buildings. Right? This is particularly happening in less developed countries, because cement is a relatively easy thing to, not cement, but concrete is an easy thing to construct buildings out of. And so it's utilized a lot in less developed countries. It's less expensive to get than, let's say, steel. And so countries that don't have the resources, they go to concrete. Aluminum is also a significant contributor, but really nothing close, right, to concrete. Again, aluminum, steel, and iron together don't equal what concrete produces. But you can see that of all iron use, this is kind of the part that has to do with the built environment. Buildings are 15%, right, of that. So these numbers are important because we could say if we can reduce its use or how we use it, if we recycle it, for instance, we can cut down on that number. If we cut down on that number, we cut down on overall output of carbon, and do not contribute in such a unhealthy way to climate change. Iron and steel going to follow suit. Again, this is all the built environment. These are other things, right, that use steel. Buildings, 32%. Right? So if we can reduce our reliance on steel, then we can reduce that number. If we can recycle steel, we can reduce that number. And again, this is on a global scale that I'm talking about. Within the US industry, and we get into this in building tech too, we're actually pretty good at recycling materials. And so we have done a lot of good work in our industry to address these issues. And in fact, it is worth noting that in these industries, it is a decided fact of CO2 emissions. You may find individuals who dispute the relationship of that to climate change, but that is not the industry's positions. Each industry has governing bodies, organizations, right, that develop consensus on its stance related to its practices. The building industries have developed a consensus in the United States, at least. You'll find it in Europe too, right? That we want to produce less CO2 because we believe that it will reduce the severity and rapidity of climate change. Okay. So material use is a big deal, right? And that's really a contributor. There's another contributor I want to talk about too, one that the building industry really can't do much about other than respond to in as judicious way as possible, but essentially building growth due to population increases or population movements to urban areas. And so globally, I know I told you about the United States, but globally, the overall square foot area that we need throughout the globe will double, right, by 2060, right? The population growth and the movement from populations to urban areas um, will necessitate the doubling of the square footage we have now. In the United States, that's not going to be the case, but the rest of the world, or at least a lot of the rest of the world, will be seeing that growth, right? Emerging and developing countries in warm climates will see those biggest growths. So like there's a couple things there. You see a lot of big construction and design firms making sure they have presence in those areas because there's a market to do business. But also they're trying to figure out how to do it in a way that meets their aspirations for ethical practices as it relates to construction and design and as it relates to carbon output. As I mentioned, it's urban growth that probably is the main driver of that change. It's, of course, demographic growth. Their populations are simply getting bigger. But also they're moving from rural areas into urbanized areas. And because of that, they're building more and more larger and larger cities. Cities are expanding. That is not the case in the United States. We don't think that way in the United States, but largely the rest of the world does. And so by 2050, population in cities is expected to double from what they were in 2010. That means we need a lot more resources. And this is a breakdown by country, and you can see, right, that the North America is the lowest, 17%, right? Africa, close to 800% increase, right? South Asia, over 200%. So this is what we're seeing in terms of worldwide global growth and where square footages is will have to be built. New buildings will have to be built. Old buildings will have to be renovated or torn down. Existing buildings will have to be expanded. And as we do that, we want to produce that new square footages in ways that are ethically sound as it relates to CO2 emissions and the contributions of the building industry to climate change. So that wraps it up for this little mini lecture. And our next will cover the steps that we're taking as industries in terms of design to address some of these concerns. Thanks so much.